Hi everyone, so welcome to Thursday's maths lesson. Today we are looking at timetables again, but we are looking at a different timetable. We've got some train timetables today. We're still looking at 24-hour time and thinking about 12-hour time as well. But you're going to be also looking at calculating more time durations today, so that's more of a focus of today's lesson. So have a little look at the review task and pause the video now and just see if you can have a go at answering the questions. Okay, so how did you get on? If it was me, I'd spend a moment looking at the timetable, so I can see that it's a timetable for a train service that runs between London and Liverpool. And we've got a Monday to Saturday timetable, and we've got a Sunday timetable, and there's a few notes at the bottom telling us when some of the trains run and when some of them don't run. We've got three tables again, so we've got the train departing London Euston, and then it arrives at a place called Runcorn. And then the train must carry on and go to another station called Liverpool Lime Street, because these are arrival times as well. So if you can imagine, this is where the train starts in Euston, and then this is the time that it arrives at the next station, and then it will let the people off the train, but it will carry on to Liverpool Lime Street, and this is where the journey ends. And you can see that we've got lots of different train times, but some of them don't run on a Saturday. So that means they would run on the other days during that week. And some of them don't run on the days of the week. They just run on a Saturday. So we're going to have to think about that as we answer our questions. So question 1 says, what is the earliest time you can depart Euston between Monday and Saturday? So we need to look at the departing Euston column, and we want the earliest time. So we can see the earliest time is 26 minutes past 5 in the morning. But that is only if you are travelling on a Monday, Tuesday, Wednesday, Thursday or Friday, because this is not the service, there's no service on Saturday. So if it was a Saturday, we'd have to look at the next train time, which would be 7 minutes past 7. That train runs from Monday to Saturday. There's no symbol to say that it's only a Saturday or no service on a Saturday. If it was a Sunday, we'd need to look at the next timetable, wouldn't we? Now, there are no symbols on here, so we just look at the earliest time departing Euston, and that's 13 minutes past 8. So let's look at the next question, which is, what's the latest time that you can arrive at Liverpool Lime Street between Monday and Saturday and Sunday? So let's now look at the Liverpool Lime Street column, and let's look at the times that it arrives, and we want the latest time. So if I go right to the bottom of the timetable, we can see the latest time is 39 minutes past 11 at night. I know that 23 hours is 11 o'clock in the 24-hour clock. Now, we've got this symbol again. So you could only take that train if it was a day of the week. You wouldn't be able to take that train on a Saturday. So we'd need to look at the column above, and that's Saturday service only. So if it was a Saturday, the latest time you could arrive is 46 minutes past 10. So that would be 10:46 p.m. in the 12-hour clock. If we're looking at Sunday, we'd need to look at the Sunday timetable again, and we still want to arrive at Liverpool Lime Street. So I'd need to go to the latest time, which is actually 28 minutes past midnight. So yeah, great. Let's look at the next question if we carry on. So here's where we start to think about calculating time durations. So just pause the video for a minute, have a look at the question. Okay, so Sam took an 11 a.m. train from Runcorn to Liverpool on Monday. I'm just going to highlight some of these things. It was an 11 a.m. train from Runcorn to Liverpool on Monday. So let's just look at whether I've selected the right information. So it's a train at 11 o'clock. It's from Runcorn to Liverpool. I know that it says it arrives at Runcorn, but remember this train also would depart around that time as well to get onto Liverpool. So how long was the journey? So this journey stays within the hour of 11 o'clock, doesn't it? It doesn't go over 11. So all I need to do is think about, well, okay, how many minutes are there between 11 o'clock and 11:21? So if I added 21 minutes to 11 o'clock, if I counted on 21 from 11, I would get to 11:21. So I know that the journey time must be 21 minutes. So there's a question at the bottom there, and it says, which other trains have a similar journey time? And I'm sure that you have looked at that and figured out that actually all of the trains that go from Runcorn to Liverpool Street have that similar time journey. And it's because it's the same journey, isn't it, each time? So, you know, if we look at the one below, the one departing at 12 o'clock arrives at 12:21. Okay, let's move on to the next question. So this one is a little bit trickier. We've got two parts to this question. Just pause it for a moment and have a little look at it. Okay, so now let's go through it. It says that Sarah and Charlie took a 4:07 p.m. train from London Euston. Sarah got off the train at Runcorn and Charlie got off the train at Liverpool. Okay, so if Charlie got off the train at Liverpool and they both got on the train at Euston, that means that Charlie must have gone further in his journey than Sarah, because Sarah just went from Euston to Runcorn and Charlie went from Euston to Runcorn and then stayed on the train and got off at Liverpool. So we need to work out how long their journeys are. So I need to work out how long the journey would be from London Euston to Runcorn for Sarah, and then how long it would be from London Euston to Runcorn and then on again to Liverpool for Charlie. So let's just see if we can find the times on the table. So it's a 4:07 p.m. train. So I know that 4 p.m. in 24-hour time is 16, and I'm looking for 16:07. So there is the train. So the train then arrives in Runcorn at 6 o'clock. So that's Sarah's journey, 4:07 until 6. And then Charlie would carry on until 6:21. So now we need to think about how long their journeys are. So I'm going to use a number line to help me think about this. You might use a number line or you might use another method. So here's one way to think about it. So if I want to look at Sarah's journey first, if I highlight Sarah in pink, I want the length of time between 16:07 and 18 hours. So 4:07 and 6 o'clock. So I'm going to think about hour chunks because that's going to help me out. So I know if I go back to 16 hours, if I go back to 4 o'clock, I know that there's an hour between 4 o'clock and 5 o'clock. And then there's another hour from 5 o'clock to 6 o'clock. So if I do a jump of an hour there, I already know that part of Sarah's journey must have been 1 hour. Sorry, I'm trying to write with my mouse, so hopefully you can see what I'm writing. Now, if I look at this part of the time, Sarah's journey wasn't the whole hour because she didn't depart the station at 4 o'clock. She departed 7 minutes later. So this is like an hour take away 7 minutes, okay? So rather than doing a whole hour jump, I need to think about what is an hour take away 7 minutes. Now I know that an hour is 60 minutes in total. So it's like 60 minutes, take away 7 minutes. And I know that that is 53 minutes because any multiple of 10 take away 7 will leave me with a 3 digit. So that part of Sarah's journey is 53 minutes. So if I look at the journey in total now from 7 minutes past 4 up until 5 o'clock, that's 53 minutes, and then 5 o'clock to 6 o'clock is 1 hour. So I know that Sarah's journey, if I write it here in pink, or maybe I'll write it in red. Sarah's journey is 1 hour and 53 minutes, okay? Now I need to think about Charlie's journey. So if I just think about Charlie's journey, I might just do my annotations in green so you can see the difference. So I know that Charlie also did a journey of 1 hour and 53 minutes, but he also stayed on the train until Liverpool. So I need to add an extra 21 minutes to our 53 minutes and 1 hour, okay? So I might just do some writing here so we can see Charlie's journey. I'll write it in green. So this is Charlie. So his journey is 1 hour and 53 minutes. But he's also adding 21 minutes. Ooh, can't see that so well. I might move it down here. Okay. So I know if I look at the number 21 and I think about 53, I know that 21 is made up of 7 and 14 because of my 7 times table. Now I can think about this because I had a 7 and 53 factor earlier. If I add 53 minutes and my 7 minutes together, then that makes another 60 minutes. So that makes another hour, 1 hour. I'm going to write that there. So now if I look at this, I've got my other hour here. And I'm going to add it to the hour that I've just made by adding the 53 minutes and the 7 minutes. And then what's left? It's the 14 minutes. That was part of the 21. So if I add all those together, I can see that Charlie's journey is actually 2 hours and 14 minutes. Okay, so I hope you can see how I did that. Okay, so moving on, there is a question here, but just for time, I'm going to let you think about that one on your own. So this is just another one where you've got to think about the symbols, because on certain days the trains run and on certain days the trains don't. So you can pause the video and have a go at that question. Then we've got some guided practice questions. Now you might think that this is the same table, but some of the information is slightly different, I believe. So have a little think about that. We've got some questions along the side. Your independent practice is a different timetable altogether. It's still trains and it's still following the same idea that the train departs the station and then arrives and then leaves and then arrives at another station. So have a go at those questions. And then your deeper thinking challenge is applying your skills of tables in a different table context. So this is a TV timetable. So good luck with that. Okay, thank you for watching and I will see you for maths next week. Bye.